scientific notation. Okay, so when do we actually need scientific notation? Mainly with what? With what kind of numbers? Either what? Too big or, although technically, can you use it with absolutely any value? Yes. In which course usually do you have to use it with any value? Chemistry across the hall. Chemists are notorious for what? For scientific notation. Even if the number is normal or okay, they still want you to put it what? In scientific notation. Okay? So scientists and engineers often work with values that are either extremely small. Give me something that's extremely small. No, an actual constant in the universe or something that has a very small attribute to it. Say again? Is that small or big though? What's the power of Avogadro's number? 10 to the power of what? 23. 23. That would be extremely large. How about extremely small? Come on. The gravitational constant is very small. What else? The mass of the what, for example? The mass of the atom or the mass of the electron or the capital G is what? Is 6.67 times 10 negative 11. Avogadro's number is very what? By the way, what is the significance of Avogadro's number? What does it tell you? I know it's a physics course, but in physics you discuss chemistry too. What is so special about number of what? Particles or molecules or atoms in one what? 1 mole of what? Of matter or substance, which is how much? 6.023 times 10 to the power of 23 molecules in 1 mole of absolutely any substance. Okay? So extremely small, like for example, let's say mass of electron, or extremely large mass of the earth. Mass of earth. Okay? All right. It becomes difficult to work with these numbers. By the way, who remembers the mass of the earth? Come on. We just did it to 5 point. By the way, the mass of the earth, everyone, is 5.98 times 10 to the 24 in kilograms, which means we'll study how to convert it to standard notation today, but it will be a lot of zeros trailing you every single time you want to write them. No one wants to do that because you're bound to what? Either what? Add a zero or forget a zero. How about something small? The mass of the electron. The mass of an electron is 9.11 times 10 to the negative 31 in kilograms as well. That's many zeros trailing where? After the decimal point. You also don't want to keep writing these all the time. Okay? That's why. So it's a bookkeeping device if you want to think about it. So whenever you want to do the numerical calculations, you can always do something in your head and then just plug in the minimum amount in a calculator, for example. Okay? The mass of the earth, yep. And the mass of the electron is that. Okay? I didn't even know my own notes. Right? Okay. So how do you write any number in scientific notation? How many parts? 2 parts. Okay? What do you call the first part, the A? In general, what do you call any number multiplying a variable in math? Starts with C. No, not constant. Coefficient. When someone, for example, in grade 11 functions, you're given a quadratic, 2x squared plus 5x plus 3. And Ms. Musa says, give me the coefficient, the quadratic coefficient. Half of you are going to say what? Oh, it's 2x squared. Nope. A coefficient is never a variable. A coefficient is just a what? A scalar, a number, which means it's only the number right before the variable. Okay? So that would be the coefficient. What is so special about the coefficient of scientific notation? It could be what? But it cannot make it to what? 10, which means what's the maximum level of the coefficient part? 9.999999 forever. Why can it not be 10? Because 10 could be represented as a what? As a 1.0 times 10 to the 1. That's why. So you always have it to be between 1 and 9 point any number you want. Okay? N is called the what? Of course, look where it is. It's the superscript, or basically the power. Okay? Where it must be an integer. You cannot have it as a pi. You cannot have it as a decimal. You cannot have it as a fraction. It needs to be an integer, a whole number. But it could be what? Positive for what? Big values, or negative for small values. Okay? So right now, let's do these real quick. I'll teach you some quick tricks to do these as quickly as possible. Again, this is going to be your quiz on Friday. Well, this is one part of your quiz. The other part is significant figures. That's why I finished both today. Yes. Oh, extras, just keep them at your desk. Thank you. Okay. Okay. All of these are in what notation? Are these scientific or standard? Standard means you're showing me the whole thing. Okay, I need to put it in scientific notation, which means what? Is there a decimal point here? If you say yes, you're right. If you say no, you're right as well. If you say no, you could be like, yeah, I don't see it. Which means it's there, but where? At the very what? At the very end. There's always a decimal point invisible at the end of any integer to keep you what? To give you a chance to do it in scientific notation. Okay, so I need to what? Go backward. So how many hops? That's why we use the comma. You don't have to use it. I just use it for easier what? For easier jumping. So go ahead. So 3, 3, 3. Can I put it right here? Can I put the decimal point here and claim it scientific notation? No, I can't, because then my coefficient part would be up to how much? 48. That's bigger than what? That's bigger than 9.99999, which means it needs to scale by 1. So that means it's actually not here. It's right here. So it's 4.8 times how many hops? Let's see. 3, 3, 3, 9, 11, 10, 11. Done. That's it. Okay? Come on, keep going. So, how about this one? 3, 3, 3, 3, and 2. 14? Yes, 14. How about this one? By the way, could I do this? Hold on. By the way, what's the power here? Come on. Nope. Up to here. 6. Can you do this? Can you? Is that technically the same number to a math teacher? But what do physics and engineering people have to care about on top of scientific notation? Significant precision, significant figures. That's why, for now, you do not put any zeros you do not need. So you cannot show this 0. Everyone, you cannot show this 0. Okay, keep going. Oh, my bad. What is this one? 3.2 times 10 to the 9, 7.285. Oh, 7. There's a 7. You have to put all the non-zeros. 10 to the what? Come on. 12. 2.47 times 10 to the 8. 5.0423 times 10 to the, is that 13? Yeah, 13. 1.3425 times 10 to the 7. 6.42 times 10 to the 14. 9.9522 times 10 to the 10. Done. That's it. That's how we do scientific notation. I'm jumping backward. Jumping backward. From here, from the invisible decimal point. And I'm counting up to 1 non-zero digit. Non-zero digit. Okay? Good? Okay, let's go to the next one. I think you flipped the page, I guess. Yes. Everyone, yes, go. Number 5. 7. We're good? Okay. What was your question anyway? I'm always interested. Oh, okay. Oh, you mean these two? Oh, okay, no problem. Mistakes happen, especially these silly ones. Okay, come on, next one. Is that the flip side? I just want to check. All right. Now my numbers are small. So do I hop backward or forward? I have to. What's happening backward? I'm showing more zeros. I need to go through these zeros. Okay. Do you remember what's the easy way? Everyone, without hopping, what's the easy way? Who remembers from grade 12 last year, or grade 11 last year, or grade 11 last term? Count the zeros and just add 1. Because you're always going to jump through all of those zeros, and then just how many digits more? 1 more. So how many? 1, 2, 3, 4, 5, 6. That's it. It's what? It's 1.6. 1.6 times 10 to the 6 or negative 6? Why? Because the number is originally what? Big or small? Small numbers stay small. It doesn't matter if you put them in scientific or standard. Good. How many here? 1, 2, 3, 4, 5, 6, 7, 8, 9. 8.512 times 10 to the negative 9. How about this one? 4.38 times 10 to the 8, negative 8. You got it. How about this one? 5 times 10 to the negative. How many? How many people agree it's 11? Negative 11. However, everyone, do any of those numbers end in a 0? Except for what? Except for that. What does it make this 0 then? Does it make it significant or insignificant? It's significant. Why? Because this, imagine if you're weighing things on a scale. If that scale could detect this 0, that's a very what? That's a very significant, precise scale, which means what? The 0 technically matters. Although, in the worksheet I got, in the website I got this worksheet from, in the answer sheet they post, guess what? They don't show the 0. So they're treating it more math than science. Because in math, it doesn't matter if you show the 0 or not. 5 is 5. Who cares how many zeros it has? But in physics, it matters. Because precision is the whole idea of doing a good experiment. All right, next. 7.9 times 10 to the negative what? I'm trusting you. 6.035. 10 to the negative 10. I know. 10. Wow. 3.91. How many here? Okay. If I don't hear objection, I'll go with 7.02 times 5. 4 times 10 to the negative 7? Yes, sir. 9.6 times 10 to the negative. Thank you. Awesome. All right. Let me just see the next one so I can give it to you right now. Okay. Oh, last time. Yeah, same one. Okay. Oh, damn it. Come on. Okay. Now we're doing the opposite. Can someone remember? What's the quick trick for this one? What's my power here? How many are already used? What's 9 minus 3? 6. You just need 6 zeros. Done. That's it. 4.5. Sorry, no point. My bad. 4.558 0 0 0 0 0 0. Done. You just need the difference between the power and the decimal points or decimal places already spoken for. So we need 6 zeros. Yeah, how about this one? 6 minus 2. I need 4 zeros. 848 0 0 0 0. 12 minus 1. I need 11 zeros. 5 5 1 2 3 1 2 3 1 2 3 1 2. So comma, 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 and so on and so forth. Oh, my bad. There we go. Yep. 14 minus 3. 11 zeros. 3 3 3 and 2. 8 minus 2. 6 zeros. 6. 7 minus 4. 3 zeros. And so on. Very nice. Just subtract power of 10 minus, how could we say it? Minus number of decimals. Number of decimals. Done. Okay. All right, let's go to the next page. Flip side. Okay. Okay. How about this one? I'm not hopping forward, I'm hopping backward. So now what do? I subtract 10 minus just what? One digit, because I'm only going what? One digit, and then I'm filling the rest. I'll give you an example. How much is here? Forget the minus. How much is here? 10. Every single one of those is in scientific notation, right? Which means how many digits before the decimal point? 1. So that means you're going to hop once, and then how many left? Not exactly. That's it. You need 9 zeros before the what? Before the 5, and between it and the decimal point. So basically, you do this 0.0000000000542. That's it. This one, same thing. 8 minus just 1. So 7 zeros. 0.0000000200016. I have to write the full thing. And so on. That's the trick. How about this one? 12. I need 11 zeros. 0.00000000000. That's 11. And then just 6521. And that's the trick.